In this lesson, we're going to be understanding the concept of a cube root. The success criteria is I can find cube roots of numbers, I can evaluate expressions involving cube roots, and I can use cube roots to solve equations. A cube root of a number p is a number whose cube is equal to p. So, a cube root of a number p is a solution of the equation x cubed equals p. The symbol, cube root symbol, is used to represent a cube root. A perfect cube is a number that can be written as the cube of an integer. Now, really quickly, I'm just going to write down the cubes of 1 through 10, and these are good to memorize. So we'll do 1 cubed is 1, 2 cubed, well, that's 2 times 2, which is 4 times 2 is 8. 3 cubed is going to be 3 times 3, which is 9, times 3 is 27. 4 cubed is going to be 4 times 4, which is 16. 16 times 4 is 64. 5 cubed is going to be 5 times 5, which is 25, and then times 5 again, which is 125. 6 cubed is going to be 6 times 6, which is 36, times 6 again, which is 216. 7 cubed, well, it's 7 times 7, which is 49, times 7 again, which is 343. And then 8 cubed, we get 8 times 8, which is 64, times 8 again, which is 512. And then 9 cubed, 9 times 9 is 81, times 9 again is 729. And then 10 cubed. This is easy. 10 cubed is 1,000. You just have your 1 cubed, and then you add the 3 zeros, because I'm cubing it this time. Now, if you know all of this, you can use the similar logic that we used when we were finding square roots of numbers by just throwing a 0 at the end, so we have multiples of 10. For instance, 20 cubed would be 8 with 3 zeros, 30 cubed would be 27 with 3 zeros, and so on. For this example, we're going to find each cube root. Well, for part A, this is read as the cube root of 8. Well, I need to figure out what number cubed, or what number multiplied 3 times, equals 8. And that's going to be 2, because 2 times 2 times 2 equals 8, or 2 cubed equals 8. So the cube root of 8 is going to be 2. For part B, I'm taking the cube root of negative 27. Now remember, when we were taking square roots, we would only take the square root of positive numbers, but for cube roots, we can take the cube roots of negative numbers. Anyway, I'm dealing with the cube root of negative 27 here, and I need to figure out what number cubed, or what number multiplied 3 times, equals negative 27. Well, that's going to be negative 3. Anytime I have a negative on the inside here, it's going to stay negative. So I have negative 3. And if I did negative 3 times negative 3 times negative 3, well, negative 3 times negative 3 is positive 9 times negative 3. That's going to be negative 27. So our answer is going to be negative 3. Over here for part C, I have the cube root of a fraction, 1 over 64. And we treat this just like square roots in terms of we would take the cube root of the top and the cube root of the bottom. So the cube root of 1 is 1 because 1 cubed is 1. It's going to be 1. And then over, the cube root of 64, well, what number multiplied 3 times is 64? And that's going to be 4, because 4 times 4 is 16, and then times another 4, well, that's going to be 64. Anyway, we've successfully found the cube roots of all 3 of these numbers, and now we're done. For this example, we're going to evaluate each expression. For part A, I have 2 times the cube root of negative 216. If you remember our order of operations, PERMDAS, where we go parentheses and groups, then we go exponents and roots, or radicals, then we go multiplication and division, and then addition and subtraction. Okay, so the first thing I'm going to do is take the root here, the cube root. So the cube root of negative 216, well, that's going to be negative 6, because negative 6 cubed is equal to negative 216. So this is going to be simplified as 2 times negative 6. Now I just have to multiply 2 times negative 6, and that's going to give me negative 12. So now we're done with part A. For part B, I have the cube root of 125 all cubed and then plus 21. Well, you could take the cube root of 125, which is 5, and then cube that again, but you'd get back to 125. Notice the cube root operator and cubing something are inverse operations, and therefore they're going to cancel each other out. So this is just going to turn into 125. Now I just bring down the plus 21, and 125 plus 21 is 146. So now we're done with part B. Because cubing a number and taking the cube root are inverse operations, you can solve equations of the form x cubed equals p by taking the cube root of each side. So for part A of this example, I have x cubed equals 216. Well, I'm just going to rewrite this. X cubed equals 216. And now, since I'm dealing with an odd exponent here, cubes in this case, to the third power, I don't need to do plus or minus the cube root of both sides. That is only for my square roots or even powers. Anyway, I'm going to take the cube root of both sides. And remember, this cube root and the cubing operation cancel, so I just have x on the left side. And now I just need to figure out what number multiplied 3 times, or what number cubed equals 216. Well, that's going to be positive 6. So my x value here is 6. So now we're done with part A. For part B, I need to simplify this side first. I need to get this n cubed alone first, and then I can take the cube root of both sides. And the way I'm going to do that is I see that I have a negative 1/4 being multiplied, so I'm going to cancel that out by multiplying by the reciprocal of negative 1/4, which is negative 4. So I'm going to rewrite this first. And now I'm going to multiply by negative 4, because multiplying by the 4 will cancel out the 1/4, and then the negative will cancel out this negative sign, so then I'll just have n cubed. So I'm going to do that on both sides. And then I get n cubed equals negative 8. Now I'm going to take the cube root of both sides. So I get n, because remember, these cancel here. The cube root and the cube, they cancel. So n equals, well, what number multiplied 3 times equals negative 8? That's going to be negative 2. Anyway, now we're done with part B. For this example, the baseball display case is made of plastic. How many square inches of plastic are used to make the case? Well, if you notice, I'm dealing with a cube right here, because all the sides are the same length, s. Okay, and I'm given a volume. But what I'm asking for is how many square inches of plastic. Square inches is an area, so I'm really asking for what is the surface area of this cube that has a volume of 125 inches cubed. So the first thing I'm going to do is write my formula for the volume of a cube. That's going to be V equals S cubed. Side times side times side, or side cubed, is equal to the volume of a cube. Anyway, I'm going to take this volume right here and then plug it into this volume. So I have 125 equals S cubed. And now what I can do to solve for S is take the cube root of both sides. So the cube and the cube root cancel, so I just get the side length. And then over here, I want the cube root of 125. What number multiplied 3 times equals 125? That's going to be 5. Okay, and then my unit's going to be inches. So 5 inches is the side length, but that's not what I'm looking for. I'm looking for the surface area of this cube. Now notice, there are 6 faces of this cube. And if you didn't know the surface area formula for a cube, the surface area, I'll just write it as SA, that is equal to 6 faces and then the area of the square. Well, the area of a square is the side length squared. So that's just going to be 6 times S squared. So to figure out the surface area, or in this case, how many square inches of plastic are used to make this case, I can just plug this 5-inch side length into our surface area formula. So I get my surface area is equal to 6 times 5 squared. And I know 5 squared is 25. And then times 6, well, 6 times 25 is going to be 150. And because I'm dealing with area here, surface area in particular, my unit is going to be square inches. And that's because I squared my 5 inches. So my unit's going to be inches squared. And that is my surface area. Anyway, the question says, how many square inches of plastic are used to make the case? Well, the case uses 150 square inches of plastic. And now we're done with this one.